So let's take up long answer questions from Unit 1 of Applied Statistics. So the most important concept over here is Gauss-Markov Linear Model. So let's see what is Gauss-Markov Linear Model. Suppose the expectations of a set of n independent random variables yi are given as linear functions of p unknown parameters beta 1, beta 2, so on up to beta p with known coefficient aij's and constant variances sigma square. Therefore, E of yi is equal to ai1 beta 1 plus ai2 beta 2 plus so on up to aip beta p for all I is equal to 1, 2, so on up to n. And V of yi is equal to sigma square covariance of yi comma yi dash is equal to 0 such that I is not equal to I dash. Now let us say let y is equal to y1 so on up to yn dash. Beta is equal to beta 1 so on up to beta n dash. Alpha j is equal to a1j, a2j, so on up to anj whole dash, where j is equal to 1, 2, so on up to p. And a is equal to alpha 1, alpha 2, so on up to alpha p. Now, let's take this as equation number 1. Now, equation number 1 can be written as E of y is equal to n, that is equal to alpha 1 beta 1 plus so on up to alpha p beta p. So that is equal to a beta. Then dispersion matrix of y will be d of y is equal to sigma square I, where I is identity matrix of order n. Now you can see after writing dispersion matrix, similarly, equation number 1 can also be written as y equals a beta plus e, and E of E is equal to 0 and D of E is equal to sigma square I, where what is E here? E is E1, E2, so on up to En dash, which is a column vector. column vector of n independently distributed errors. That is E1, E2, E3, so on up to En. Now see this, we will take it as equation number 3. So hence, the equations 1, 2 and 3 are known as Gauss-Markov Linear Model. So in these equations, there is an unknown parameter. What is that unknown parameter? All betas, like we can say beta j's, are referred to as effects or regression parameters. So like beta 1, beta 2, beta 3, beta, so on up to beta n, whatever betas we have used, those betas are called as effects or regression parameters. Now see, when every beta parameter is a fixed constant, then the model is known as fixed effect model. And in this model, what happens? If one set of the coefficient, for example, AI1 is equal to, for all I is equal to 1, 2, so on up to n, then E of yi is equal to beta 1 plus AI2 beta 2. Sorry, here you have AI1. AI1 beta 1 plus AI2 beta 2 plus so on up to AIP beta p, where I takes values from 1 to n. Now here, what is beta 1? Beta 1 is an additive constant. And it is called as general effect. So here, as you can see, beta 1 is an additive constant and it is called as general effect. Okay. If suppose beta 1, beta 2, so on up to beta n are considered as random samples from a distribution of beta 1 bar, beta 2 bar, so on up to beta p bar, where beta j bar is a random variable containing one specific realization beta j, or random samples beta 2, beta 3, so on up to beta p, from a distribution of beta 2 bar, beta 3 bar, so on up to beta p bar, where beta 1 is an additive constant, then this model is called as random effects model. Similarly, when some distributions of beta 1, beta 2, so on up to beta p are random samples and remaining are fixed effects, then it is called as mixed effects model. Okay, so let us write this point now. So if beta 1, beta 2, so on up to beta p are considered as random samples from a distribution of beta 1 bar, beta 2 bar, so on up to beta p bar, where beta j bar is a random variable. So these all are random variables containing one specific realization beta j or random samples beta 2, beta 3, so on up to beta p from a distribution of beta 2 bar, so on up to beta p bar, where beta 1 is an additive constant. Then the model E of yi is equal to ai1 beta 1 plus ai2 beta 2 plus so on up to aip beta p for all I takes values from 1 to n is referred as random effects model. Similarly, when some distributions of beta 1, beta 2, so on up to beta p are random samples and remaining are fixed effects, then the model is known as mixed effects model. Mixed effects model. Now we will see how to classify the models. So classifying the models depending on the values of aij's. So the first point is, if aij's are indicator variables, if aij's are indicator variables, that is aij is equal to 1 into 0, then the jth effect beta j is present in E of yi. And this type of model is known as analysis of variance model or experimental design model. Now coming to the second point, if aij's are observed values of some independent variables, xj for all j takes values from 1, 2, 3, 4 up to p, such that E of yi is equal to beta 1 plus beta 2 xi2 plus beta 3 xi3 plus so on. Where what is this beta 1? Beta 1 is general effect. And what are these xi2, xi3, what are these? These are regressor variables. Okay. Then this type of model is known as regression model. Moreover, regression models can be further classified into several types. Depending on xij values. So what are the different types of regression models? Number one, functional regression model. Number two, conditional regression model. Number three, stochastic regression model. Number four, error in variable regression model. And number five, random parameter regression model. Okay, now let us understand about each one of them. So first, let's see what do you mean by functional regression model. Functional regression model. So the model in which values of the regressor variables, that is xj's, cannot be varied by the experimenter, that sort of model is called as functional regression model. Okay. So the model in which values of the regressor variables xj's cannot be varied by the experimenter is known as functional regression model. Now let's see the second one. What is conditional regression model? So what is conditional regression model? The model in which values can be varied. Where the values cannot be varied, that is functional. And where the values can be varied, it is conditional. Okay. So the model in which values of the variables xj's can be varied by the experimenter is known as conditional regression model. Now let's see the third model. Third model is stochastic regression model. Stochastic regression model, okay? So when y, x1, so on up to xp is considered as a vector of random variables, with yi, xi1, so on up to xip as a particular realization of the random vector where I takes values 1, 2, so on up to n, then the model is known as stochastic regression model. Now let's see what is the fourth type of regression model, that is error in variable regression model. So what do you mean by this? The model in which all the values of yi's or xij's cannot be observed correctly, but only some of the values of yi and xij which are mixed with measurement errors can be observed and forms a linear regression relation between their values, then such type of model is called as error in variable regression model. So the model in which all the values of yi's or xij's cannot be observed correctly, but only some of the values of yi and xij which are mixed with measurement errors can be observed and forms a linear regression relation between their values, then the model is known as error in variable regression model. Now this is the last model of regression, that is random parameter regression model. So when the coefficient vector beta is considered to be stochastic. So stochastic we have understood from the third type of regression model. So if the coefficient vector beta is considered to be stochastic with a distribution which is independent of E, then the model is called as random parameter regression model.